If the speed is doubled, dynamic pressure will be 4 times greater, as the factor in the equation is speed squared. Dynamic pressure is half rho v squared. The dynamic pressure is proportional to the density of the air and the square of the speed of the air flowing over the aircraft, and is denoted by the symbol Q, in either upper or lower case. That is 0.5 times 1.225 times 52 times 52, which equals 1,656 newtons per square metre, or 16.56 hectopascals. The equation total pressure equals static pressure plus dynamic pressure can be rearranged to show that dynamic pressure equals total pressure minus static pressure. A way of subtracting the static pressure from the total has to be found, and this is achieved by way of one or more vents located on a surface parallel to the airflow, usually on the fuselage, which will sense static pressure. The two static pressures, essentially the same pressure, cancel each other out, and the diaphragm will sense only dynamic pressure. Movement of the diaphragm moves a pointer over a scale, so that the changes in dynamic pressure caused by changes in airspeed can be observed by the flight crew. This isn't a problem, since the pilot needs an indication of dynamic pressure, which is what the instrument, the airspeed indicator or ASI, provides, being made in such a way that it indicates the square root of the dynamic pressure in nautical miles per hour, known as knots, or in some old aircraft, in statute miles per hour. True airspeed is the actual speed of the aircraft through the air, and is the only real speed of those considered so far, all the others being dynamic pressures. The ASI is merely a pressure gauge calibrated to read as speed. TAS is EAS divided by the square root of the relative density. That is the ambient density as a proportion of the ISA sea level density. The ASI is calibrated to ISA sea level, so it will only read TAS if the density is 1.225,